This video is where we're going to answer the question of how good are our approximations and how can we find that out? So it features, if I can find him, good old Theodore, who is, of course, sleeping as always. That's not true. My cats don't sleep always. They like to be up from about 12 a.m. to 4 a.m. That's their favorite time. Anyway, we're going to talk about correlation coefficients, and we're going to look specifically at the last two examples. So over here, we use the B and the M. We didn't use the R squared. We won't really talk about R squared today either. We'll talk mostly about R today. That's what's called the correlation coefficient. I said this line really fits the data well. Look at our R value. What is that really close to? I don't know. We'll talk about that in this video. Looking at this other one, it still fits it really well. It's not as perfect as the last example, but it still fits it really well. And our R value is 0.95. It's also really close to the same thing. They're both positive too. That has something to do with it. Something to do with something. So let's get into what is that correlation coefficient? What does that R value actually talk about? So the R value is always between -1 and 1. It's impossible to have an R value outside of that region. Anywhere between -1 and 1, fair game. We're going to talk about what that means. So if R is positive, that means one thing. It means there's a positive relationship or an increasing relationship. Okay? An increase in one leads to an increase in the other. Increase in year, increase in consumption of gas. Increase in temperature, increase in number of chirps, and vice versa. Okay? Negative R value would be a negative or inverse or decreasing relationship. We didn't have an example of that yet, but you know what decreasing looks like. Going down from left to right. And the closer, here's the things that you may not know, the closer that the R value is to 0, the less related, the more scattered the data. And the closer it is to a +1, which we just saw in our examples, or -1, the less scattered or more related the data is. So we could make a little table, right? Let's, I should have given some space for this. Let's look at what happens if we have a positive R and a negative R. Let's say that R is close to 0. And R is close to 1 or -1. I just want to give you a couple examples of what, because there's kind of like 4 cases, right? Positive and negative does something, close to 0, far from 0 does something. If something is positive and close to 0, well then it's not very related, but there's a general like positive relationship. Like this stuff's not really related, but it is kind of going up and to the right. Whereas if it's positive and the data is close to +1 or -1, well, now the data is still going up and to the right, and it's much more closely related. So when the R value is close to 0, very scattered, less related. Close to +1 or -1, it's very close to that line. Another way you could think about, right? This is really close to the line in this last case. But in the second to last case, right, it'd be kind of like lots of points far away. This is not a precise definition, but a way to think about it. Similarly, right, if R is close to 0 but negative, well, now it's a decreasing relationship. Okay, so on average, it's going down. But they're really spread apart. But if it's really close to -1, right, they'll be really close to that best fit line. It's still going down. Okay, so those are kind of the 4 things that we'll kind of think about. And let's just say closer to 0. Closer to 1 or -1. So if we have an R value of 1, that would actually be perfectly related. That means if R value is exactly equal to 1, everything's on the same line. Now, our value of 0, it's not going to be related at all. just random points. That brings us to our next point, a cautionary tale. I'm going to get on my best old man voice and try to scare you from going out into the forest at night. R is only No, I'm not doing that. R is only useful if the data follows a linear pattern. So look at all these scatter plots below. These all have an R value of 0. But that R value of 0 is useless because none of this data is linearly related. This kind of looks like a quartic function, like a polynomial or maybe a sine function. This is just a rectangle. Okay. This is a smiley face, for goodness sake. We've got 2 smiley faces, a circle, 4 dots. All of these have R values of zeros. These are all related, right? All these scatter plots have a very, very noticeable pattern, but none of them are linearly related. So our R value is garbage. Okay. And there are other like correlation coefficients that you can talk about for other nonlinear models, but this is what we're focusing on right now. So let's not worry about those. So if we have linearly related data, this is what it could kind of look like. So again, you can see, right? If it's 1, it's perfectly related. This is close to 1. It strongly follows this line, right? And then things are getting weaker and weaker, right? As the correlation coefficient gets closer and closer to 0, this one, it's only very weakly, it's weakly related, weakly positive. And then when it's 0, well, it's just a mess. Looks like me playing darts. Okay. And then again, weakly negative. It's going down now, but they're pretty far apart. Getting stronger, still going down. Real strong, going down. Perfectly strong, you might say. All right, so let's find the correlation coefficients for the last 2 examples that we did. That's why I said keep them up in Desmos, and explain what they mean in the context of each problem. So let's start with the crickets chirping. Our correlation coefficient, it said, was 0.9509. For crickets, this was example 1. Again, it's positive. R is positive, so it's increasing. And it's strong. Close to 1. This means that there's a positive relationship or a direct relationship between temperature and frequency of cricket chirps. And I would even say there's a strong positive relationship. All right, and that's how we'll answer this first one. For the second example, it's actually disappointingly similar. Right, the second example, R was 0.9965. Again, this is a positive R value, so it's still increasing. And it's very, very strong. There's no line in the sand between strong and very strong, but this is definitely very strong. Okay, so again, we'll say a very strong positive or direct relationship between here and gas consumption. I think it's in the US, but I don't know if the problem's specified. That's what this is sort of looking for. That's how we can interpret coefficients. So try it now. Match the following graphs. I have 4 scatter plots for you with the correlation coefficient. And what I recommend is that you do this backwards. Look at the first correlation coefficient and ask yourself what this describes. Then see if you can find it on the graph. Pause the video, see if we get the same answers. So this first correlation coefficient is negative, so it should be a inverse or decreasing relationship And it's not really close to 1. It's not that strong. It exists, not close to 0 either. But it's not that strong. So are any of these negative relationships not that strong? Yeah, this one. Also, when I'm just looking at the graphs, this is not a line. This is a parabola. What's this doing here? Right? We're not going to use an R value. So that's the one where it says it doesn't matter. See, this is not a line. Get out of here. Angry face. All right, R value of 0.9, that's positive, so it should be increasing. And it's pretty darn strong. The points should be pretty close together. All right, yeah, that's definitely A. Or so B. Oops. Can you read that? That's the letter B. And again, right, this is negative, medium strength. This is positive, very strong. One is if something's not linear. And this last one is negative and very weak. Almost non-existent. Does that fit with this? Yeah. Like maybe you could draw a line through this. I don't know. And maybe the slope is negative. It just looks like random nonsense. I don't see any linear correlation going on here. That's how you can visualize the R values. That's the whole section. Let me know if you have questions, and best of luck.